Welcome back. In this step, let's focus on the terminal operations in streams. The result of a terminal operation on a stream is typically one value. It might be a sum of the numbers, it can be average of the numbers, or it can be minimum or maximum, or it can even be a list. So there is one return value at the end of a terminal operation on a stream. We already looked at the most basic terminal operation to do the sum, right? We used reduce. How did you do that? I'll use the int stream that we learned in the previous step. Int stream dot range. Let's say I would want to sum up the first range 1 to, let's say I would want to sum up the first 10 numbers. So I can say int stream dot range 1 to 11, and I would want to add them up. So reduce, the initial value is 0, and with each of the next numbers n1 and n2, what do I want to do? I would want to add them up, right? N1 plus n2. Very simple. And enter. You get 55. Isn't this cool? Earlier we had to write a lot of code to find the sum of 10 numbers, temporary variables and all that kind of stuff. No such thing is needed with functional programming, because we are able to send a function as one of the parameters to the reduce method. Think what reduce is doing, right? It's taking a stream of numbers and it's converting into one result value. That's what is called a terminal function. Now there are other terminal functions as well. Let's create a simple list.of. Let's say there are a list of few numbers, right? 34, 53, and I would want to find out the maximum number in it, right? How can I do that? First thing is we would do a stream, and then there's a method on the stream called max. Can we call it as it is? Nope. What does it say? It says method max in interface stream cannot be applied to given types. It says you need to pass in a implementation of the comparator interface. If you remember the discussion that we had when we were discussing about collections, we talked about a ascending student comparator, right? So we wanted to have students in increasing order. So we created an ascending student comparator implementing the comparator of student. And what did we do? We implemented a method and we returned integer.compare these two student IDs. So this would help us in creating a comparator which would be allowing us to compare students. Over here, what do we want to compare? We would want to compare simple numbers, right? And we are doing functional programming. So we don't want to create a big method or big class like this. I can create this class and try and use it here. But let's think functionally. Now, how do I create a function which would be doing this comparison for me? The way I can do that is by saying n1 comma n2. So we are going to compare two numbers, right? Instead of students, we are going to use integers. So we are going to compare two numbers, and what do we want to do with them? We want to do integer.compare n1 comma n2. Okay, that's cool, right? If I just press enter now, I should expect the return value. Oops, no, I get an optional back. Optional is one of the types which is introduced into Java in Java 8. Think of this. If this list does not have any values, what should be the return value? What should be the max? Typically when we do programming, null, right? That's what we would expect as the return value. However, using nulls is a very, very bad practice. And that's where Java brought in something called optional. When I'm doing max, then there might be a result or there might not be a result. So optional helps us in those kind of situations. You can query an optional object and check if there is a result on it. For example, I can say $24 dot and see the methods which are present in there. You can ask, is there a value present? So I can say is present. What does it tell me? Yes, there is a value present because there is a maximum in this specific thing, right? So let's execute that. How do I get the maximum value? So I'm going back to this code. How do I get the maximum value? It's by saying get. And you are getting 53 back. Quickly revise what we have done until now. We discussed about the most basic of the terminal operations, which is reduce, right? So reduce basically reduces the list of stream into a single result, and the function which we are using to reduce is sum all them up. And we also discussed about the second terminal operation, which is from a stream. What we are doing in here is we want to find out the max, and we are sending a comparator implementation in here. We are saying n1 comma n2 within parenthesis and using the lambda expression operator and saying integer.compare n1 n2. So this is how you can compare the numbers. So this would actually put the numbers in ascending order. To find the max, it would pick up the last element and it would return that back. So it returns back a value of 53. Now you might have a question on how is this code the same as this code, right? It's not really exactly the same. Here we are using student, here we are using numbers, but you can get the drift, right? So this is comparing students and this is comparing integers, but here we have a lot of code to do that. So here there is about 6 lines of code. How is all that getting replaced by just a simple statement in here? There is a concept called functional interfaces. At the end of the discussion on terminal operations, we will get to functional interfaces and discuss that in detail. And the other question you might be getting is, what are the other operations I can do on an optional? We will discuss that as well a little later. In the next step, we will discuss a couple of more terminal operations on streams. Until then, bye-bye. Welcome back. In the previous step, we wrote code to get the maximum from a list of numbers, right? How do I get the minimum? And what are the other things you can do as terminal operations? That's basically what we would be looking at in this specific step. Let's start with the same code that we started with earlier. So to get the minimum, all that you need to change is to change it to min. And you can get the minimum out of the list. Minimum is one of the other terminal operations which is present on a stream. Now, let's say from this list, I would want to get the list of odd numbers. I would want to filter them out, and at the end, I would want to have a list of just the odd numbers present. How can I do that? Think about it. Pause the video in here, and from this list, I would want to get only the list of odd numbers. How can I do that? You can easily guess the first step that we would need to do is to do a filter, right? So we would want to filter this, and we would want to identify only those elements which are odd, right? So which are odd. So e mod 2 is equal to 1. So this would return, what would this return? This would return all the elements which are odd, right? So I can say for each, this is another terminal operation, right? So we talked about for each earlier, and say s for each. Let's use e because element is much more better word for me. It does not matter if it's e or s. All that I need to make sure is I use the same letter in here. Right now, if I press enter, what would it happen? It is printing the odd numbers out. Now, I don't want to print them out. What I want to do is I would want to convert them to a list. So I would want to take these filtered values and convert them to another list. The terminal operation I want to do in here is I would want to get a list as output with the values which are filtered. How can I do that? That's where there is another method called collect. What do I want to do? I would want to collect to a list. So it's collect, and within the parenthesis I put collection dot toList method call. So this is a static method called toList. So what we are doing in here is we are saying collect it as a list. Oops, I'm getting a compilation error because I got the static thing wrong. So it should have been actually collectors. It's not collection anymore, it's collectors dot toList. Be careful about it. And now you would see that we are getting a list as the output, which has 2 numbers coming out. Now I'll leave you with 2 exercises for this specific set of things that we were doing with terminal operations. The first exercise is to pick even numbers into a list. So until now we have been picking up odd numbers into this list. I would want to pick up even numbers into this list. How do I do that? That's number 1. And the number 2 is create a list of the squares of the first 10 integers. I want to create a list with the squares of the first 10 numbers. Now you can pause the video in here and try those exercises. I hope you had a chance to work on the exercises. Let's solve them one by one. The first one was to identify the even numbers and collect them into a list, right? So all that I need to do is change it to 0. Cool, right? Now you have 12, 34. That's awesome. So 12, 34 are the 2 even numbers in this specific list. The second exercise was a little bit more complex because we wanted to find out the squares of the first 10 integers and take it into a list. So if I want to get the list with first 10 integers, we know how to do that, right? So we use intstream. Intstream.range and say 1 to 11. So as we discussed earlier, the upper bound is exclusive. So this would generate numbers from 1 to 10. And from these numbers, what do we want to do? We would want to square them up. So what do we use first? Map. So I can say map E to E star E. Now, one of the important things is the type of the return thing. It returns something called a integer pipeline. So the important thing is this is not really a stream. So it's not a stream of integer pipeline. If you look at the integer pipeline, it's not really a stream in the traditional sense of the word stream. So it's not a implementation of the stream interface. Now, what I would want to do is I would want to convert this int stream into a stream, and the operation which is available is called boxed. So I can take this thing and do a box. This would convert it into an stream of integer, and once I have a stream of integer, I can use the collect on it. So I can use the collect. So inside the collect, what do we want to do? Collectors.toList and press enter. Now we have the list of the first 9 squares. Actually, the 10 should have actually been 11, right? Because it's excluding 10. I would now say 149 to 100. So this is the list of first squares. One of the most important things with JShell I found is when I use JShell, I would actually be much more focused because I'm typing it perfectly well. And when I start using JShell more and more, I see that it improves the pace at which I can type in code. So if you're trying to practice something new, I always recommend to start with JShell, especially because you can focus on what you want to type and immediately see the results. And that's exactly what we have been doing in the last few videos with functional programming. Wherever possible, I was actually trying to switch to JShell and give you a feel of how you can learn things with JShell. I hope you are having an interesting time learning functional programming within 28 minutes. I'll see you in the next step where we will try and understand what's happening in the background. Until then, bye-bye. Welcome back. In this video, we would be talking about optional. We initiated a discussion about optional in the previous step. Let's look at all the important methods that are present in optional and where you can use an optional. Optional is one of the new features which is introduced in Java 8. It is majorly meant to avoid null pointer exceptions. Typically, when we are having a list of values and we are trying to process them, and at the end of it, If there is no result, typically we return null back. And what could happen is the consumer of that API might not know that you are actually returning a null back. So instead of using an object, you can actually use an optional as the return value. Let's see how can we do that. Now let's create a simple example. Let's say I would want to create a list of a few numbers, right? 23, 45, 67 and 12. I'm just creating a list of a few numbers and I would want to filter them, right? So first thing is I have to convert them into a stream. So stream, and then I would want to filter only the even numbers from this, right? So n mod 2 is equal to 0. So this would give me the filter of even numbers. After that, I would want to find the max among them. So how can I do the max? We learned earlier. So n1 comma n2 and followed by integer dot compare n1 comma n2, right? So this bracket is to close this one, and between this you have n1 comma n2. What are we doing with? Integer dot compare n1 comma n2, right? So this would return the max. As we found out earlier, this returns an optional back, right? So if I want to get the value from the optional, I can say $39 dot get, right? $39 is kind of a temporary variable that JShell creates for you. So I'm using $39 dot get, and you'd get the value 12. So among the even numbers, the maximum is 12. Optional also has methods to check if there is a value. So I can say is present. So is present? Yes, it is present. So there is a value present. Now let's say I'm creating a stream which does not have a even number. So I can say Control A to go to the start and remove the even number out. So now there are no even numbers. I'm trying to find out the max and there are no even numbers out. So this is going to return me another one, 42, and you can see it's returning back optional dot empty. It's not returning null back. There are no even numbers, so we are doing a max, and it's not returning a null back. What it's doing? It's saying that it's optional dot empty. Now I can do same operations on this. So if I say $42 dot is present, what does it do? It says false. There is no element present in here. Let's say I would want to have a default value assigned. So I can say $42 dot or else 0, and it returns 0. So I can use it in here as well. So in the previous piece of code, I can say or else 0. So what does it do? Let's go to the start, Control A, and execute this line of code again, now with a number present, 34. You can see that if I say or else 0, what we are doing is we are assigning a default value. If a number is present, it would return 34 back. Otherwise, it returns 0 back. So optional is just a way to avoid returning nulls. Whenever you are returning something which might exist or might not exist, then you can return a optional back. And that's what most of the methods in these streams do. Max might be there, might not be there. Minimum might be there, might not be there. In all those kind of situations, streams return an optional back, and then you can use or else to assign a default value, or you can directly call a get if you are sure that there would be a value. Okay, in this step, we took a behind the scenes look at optional, and we'll continue the behind the scenes stuff in the next step as well. We will see what's happening behind these Lambda expressions. I'll see you in the next video. Until then, bye-bye. Welcome back. In this step, we would start looking at what's happening behind the screens with Lambda expressions. What is happening when I type a method like this, element hyphen or a Lambda expression with element mapping to element dot ends with eth? What is happening behind the screens? How is it really working? All the magic of this is based on something called a functional interface. Okay, I know we love practicals, so let's do that. So let's create a new class, and I'll call this Lambda behind the screens runner and give it a main method. And let's type in a very simple piece of code, right? So I would want to just get a list of a few values, let's say 23, 43, 34, and 45. And out of this list, let's import list in java.util. What I want to do is filter out odd numbers. So filter and say the logic, right? Number, only get me those numbers which are odd, and even within those, oops, before the filter I need to convert it into a stream. How can I forget that? So stream dot filter, and now let's format it a little bit. So we have a list, we are doing a filter, and out of, for each, let's say I would want to print them. I would want to say system.out.println E. Cool, right? So I can format it to make sure it's clear. So for this stream, we are filtering it and we are printing each element to the console. What would happen when I do this? You know, it's printing 34. So we are printing only even number in here, right? So let's add in a few more even numbers, 36, 48, so that we have a little bit more output to play with. Now 34, 36, and 48. That's cool, right? So we have a list, we are filtering it, and we are doing a foreach. Now, what is happening behind the screens? How does this code get sent out to this filter method? If I look at the signature of the filter method, if you hover over it, you can see that it's taking a predicate. So what it's saying is you're using a stream of integer, and the filter accepts a predicate, a class of type predicate. That's what it's telling me, right? So let's go to this one. So I just need to press Control or Command and press this. Control or Command and press this. And you would go to that method, and this is the signature of that specific method, right? So what is it saying? The signature of this filter method is filter, and it accepts something called a predicate. What is this predicate? If you again do a control and or command and hover over it, let's go there. So if I go to the predicate, it says it's a functional interface. Now the functional interface which is present in here is something called test. Now let's copy this test over here. So what we have in here, we have predicate is a interface, and the predicate interface has a method called test. And if you look at the predicate interface, that is the only method which will not have a implementation. As the only method without a default implementation inside the predicate. So now, how does this get mapped to a implementation of the predicate interface, right? So if I have a method which is accepting an interface, then I can only send implementations of that interface, objects of the implementation of that interface as parameters to it. So how is it happening? Now let's do one more thing, right? So n is equal to n maps to n mod 2 is equal to 0. What I'll do now is I'll create a implementation of the predicate interface. Let's say, because I would want to use integers, right? So here there's a list of integers, so we would need to create a predicate of integer, right? We would want to create an implementation of that. So let's create that right now. So I'll go here, let's go out here. So class, I'll call this even number predicate, right? We want to find out the even numbers, and I'll say it implements. What does it implement? Predicate of integer. And let's do a control one, add unimplemented methods. Oops, you can see that there is a test method. That's exactly the method that we saw earlier, boolean test t. So instead of t, we are using integer, so this becomes integer. And r0, let's call it number. Now over here, what I can do is I can implement the test method. What I would want to do with the test, when is it an even number? So I would say return number mod 2 is equal to 0. If number mod 2 is equal to 0, return true because this is an even number. Otherwise, return false, right? So now I would take this even number predicate and let's create the same piece of code again. New, I need to create an even number predicate, right? So new even number predicate. Let's run these pieces of code again. You can see that the same output is being printed by both these lines of code. That is exactly what is happening when you are passing some logic. When you are passing some logic to the filter method, what is happening is in the background, the Java compiler creates a implementation of the functional interface. The most important thing about a functional interface, like the predicate, is that there would only be one method which will not have a definition. And basically what we are doing when we are creating a Lambda expression is providing an implementation for that specific method. So what we are doing in here is we are saying take the only method which is not implemented and provide this as the implementation for it. So what would happen is implementation of the test method would be created with the logic that you are passing in here. That is what is happening in the background when I just say filter and pass in a method to it. This specific interface is called a predicate because what it does is it evaluates and returns whether it's true or false. So the predicate interface returns if the test has passed or not. Now, I would leave it as an exercise for you to do the same thing with the for each interface. So take the for each, see what's happening behind the screens and try and create an implementation of it in here. So try and create exactly what's happening in the behind the screens for each in here, and I'll see you in the next step. Until then, bye-bye. Welcome back. In this step, let's look at what is happening behind the for each, right? So if I do a control or command and press this, I'll be able to get the declaration. So it says it's consumer. So it says consumer, right? Let's copy that in. So for each is based on a consumer. For each is a consumer. Filter was a predicate, right? For filter, we were passing in a predicate. So let's put that down here. Now, for each is a consumer, and what's inside the consumer? Control and click, and there is a simple accept method, right? So let's take that as well over here. So what does the consumer define? A consumer defines a accept method, and what is it returning back? Nothing, right? That's why it's called a consumer. What do you expect a for each to do? You take the element and do something with it. Here we are actually printing it to the console. So you don't really need to return anything back. You directly consume it. So behind the for each is something called a consumer interface. Now, how do I create an implementation of the consumer interface? Let's do that right now. So what do you want to do is create a consumer of an integer, right? So let's do that. So class system out consumer. So I'm trying to give it a very creative name. Don't really worry about what the name is. So consumer of integer, right? Implements. Now, control 1 and unimplemented methods. And over here, what do we want to do inside the accept method? System.out.println your argument of 0, right? Argument of 0. Let's rename to number. Cool. Now, over here, what should I do? I should replace this with a new system out, our own creative system out consumer. Okay, the output does not change, so we are printing it twice. The first one where we are actually using lambdas, and the second one we are actually creating even number predicate system out consumer, our own custom defined implementations. The most important thing for you to understand is behind the for each is an interface called a consumer, and what we are creating when we do this is we are creating the definition for the accept method inside the consumer interface. So in the background, accept an implementation of the consumer is created, and that's what we see in here. In the next step, we would look at what happens behind a mapping. We'll do that in the next step. Until then, bye-bye. In the previous steps, we looked at what's happening in the background of filter and for each. Now let's look at what's happening in the background for a map method. Let's say now I would want to map all these even numbers and print the squares of them, right? Some kind of a mapping. So n star n. Now what would happen behind the screens of the map method? That's what we are interested in. So if I do a map of n star in over here as well, let's see what the output is. Yep, you have bigger numbers. Both these are exactly doing the same thing. Now we can now look at what's happening in the background of a map, right? What is happening? I'll open in the declaration as usual. Let's copy this down here. For the map, behind the screens, we have a map interface, right? So what do we have? A map interface, and the map interface is accepting a function. Control and click. And what is the interface? What is the functional interface which is present in here? This is the functional interface, right? So let's now look at it, right? Over here, we are using an interface called a function. What does the function interface do? You pass it a value, it returns another value back. And also you can look at the map, it returns a stream back. And the function, it takes one object as the input and returns another object as the output. So what we are doing in here is we are actually creating the definition for the apply method. What we are saying is the input is n, take it and give me the output n into n. So let's now create an implementation for this stream, right? So I'll call this class square, or let's square mapper, number square mapper implements. What do we implement? Oops. What do we implement? We need to implement the function interface, right? So function of what is the input type? Input type is integer. What is the output type? Is also integer because we are just doubling it, right? That's cool. Now control 1 and unimplemented methods, and you can see that over here we get a apply method. That's the thing which we saw in the function interface. Cool, right? Now I can go ahead and implement it in here. So I get a number arg0 number. I would want to send number star number back, right? Now I can say number square mapper. Over here I would need to create a new number square mapper and run this, the same output, right? So the important thing for you to understand is what happens behind the screens when you write code with Lambda expressions. What is happening behind the screens is you're creating implementations of the functional interfaces and an instance of that implementation, and that is what is being passed out to the filter method, and that is what is being passed to the map and the for each as well. So what we are looking at are three of the most important functional interfaces. A function is one of the functional interfaces which takes an input and gives you an output. It's like any function, right? A function, typically you give it an input, it gives you an output. A predicate looks at an input and tells either true or false. A consumer takes the input and consumes it, so it doesn't return anything back. So these are three of the most important functional interfaces, and we tried to give you a background look on what's happening behind the screens when you're writing functional code. I'll see you in the next step. Until then, bye bye. Welcome back. In this video, let's focus on another important functional programming concept called method references. Let's create a new class. I would call this method references runner and create a main method. And over here, let's start with a simple piece of code. Let's create a list of string. So list of, let's take our favorite example, ant, bat, cat, dog, and elephant, right? So let's say I would want to, let's import the list. Now from this list, let's get a stream out so that we can do stream processing on it. And once I got a stream out, now what do I want to do with it? I'd first want to get the length of it. So how can I get the length of each one of this? I would want to use a map, right? So map, take it as s and say s dot length, and after that, for each, I would want to print it to the output, right? How do we do that? System dot out dot println and s. What do you want to print? The argument which is passed in, right? Cool. So this is what we looked at as how we can map it to a length and print it, right? So what would be the output? Try and guess it. 3, 3, 3, 3, 3, and 8, because the first three strings have 3 letters each, and this has a length of 8. That's cool. Now you might be asking, what has this got to do with method references? Why are we talking about all this now, right? I'll tell you why we are talking about all this stuff now. Let's look at this specific thing, right? All that I'm doing is s, I'm mapping it to system.out.println s, right? Let's copy this piece of code again and paste it down here. And what I can do is do some little magic. So I'm removing all that, and actually I'm taking out the dot and replacing it with colon, colon. So colon, colon, right? Now let's run this program. Let's see what would happen. Aha, the same output, right? So we first printed 3338. So 4 3s and 8 and 4 3s and 8. So the same output is being printed by this as well. So this method reference is a shortcut for this. So what we are doing in here is each string, take it and print it. Instead of going to the complexities of doing all this, all that you need to do is to say system.out. So the way you can think about it is, on the left hand side is the class. So system.out is the class, and the method which we'd want to talk to is println, right? One of the things is, let's say I have a consumer method directly defined in here, right? So let's say I have a static method which is defined in here, public static void print. Let's just say I have a print method. It takes a string as an input, and all that it does is system.out.println. So this is a static method which is printing string, str, right? So it's printing a string. So if I want to use this one in here, all that I would need to do is take the name of the class. So replace this with the name of the class, and the method which we want to use is print. Actually what we have in here is a length, right? So this should have been integer. So it should be integer number. Now you can see that this code would exactly do the same thing as it was doing earlier. What we are doing in here is using a method reference. What is happening in here is we are calling this method and passing whatever is the output. Each element would be passed to this method and executed. and this method reference is a shortcut. So instead of saying for each s call method reference runner dot print, instead of doing this, what we are doing is we are saying method reference runner colon colon print. That's a simple example for a method reference. In here, method which is being consumed is a static method, right? So we are calling a static method in here. The thing is, method references also work with a method which is being called on an instance, right? Here I'm calling s dot length. We know that s is a string. So what I can do is I can replace this by string colon colon length. So not only static methods but also instance method calls can also be replaced by a method reference. Let's run this. Same output. So what happens is on the string instance, the length method is getting called. So you can look at these two pieces of code, right? So you can look at this and look at this. You'd find that the second piece of code is much more readable than the first piece of code. The reason why we go for method references is to make the code more readable. Now, let's take an exercise for the method reference, right? I'll copy the code which we wrote in JShell when we were talking about optional. I'll take this and I'll put this down in here. Let's format it. Oops, there's a compilation error. I missed a semicolon, so let's do this. So what we are doing in here is we are finding out the even numbers and finding the max of them, right? So this would finally return a integer max is equal to this, and let's do a sys out of that, sys out of max. What would happen? It's printing 34 as the output, right? What I would want to do is I would want to replace this with a method reference. I would want to replace this and also this with a method reference. Think about how you can do that. You can pause the video in here and try and convert these two things into a method reference. Okay, welcome back. I hope you had a chance to try to convert these into method references. The thing is, here what we are doing is n mod 2 is equal to 0, right? This is kind of custom logic, so it's not really easy to convert it into a method reference. So what we can do is we'll create a static method for it, right? Public static is even. So I'm saying I'm going to create a method called is even, and it would accept an integer I, right? I'll accept an integer instead of calling it a number. I would say I instead of I'll call it a number, and it would return a boolean back, right? A filter will return a boolean back, and it returns if number mod 2, the same logic which we have in there. So now I can use is even instead of it here, right? I can call this. Nope. One of the things with method reference is you have to give the class name, right? So now this would work. So we have changed the filter to use a method reference with the static method, right? However, with the max, we are already calling one method, integer.compare, right? The integer.compare accepts two parameters. Even those kind of things you can actually replace with a simple method reference, colon colon compare. That's it. Now if you print, execute the code, last line would be 34 and nothing has really changed. The idea behind this step was to introduce you to the concept of method references and show you the fact that method references can be used with both static methods as well as instance methods. And also we saw that a method reference can be used when the number of parameters are greater than 1. So you can see how simple the code looks now compared to this code. This is the code we really started with for integer.max to find the max of the even numbers. And you can see that this code is not as readable as the code which is right below, right? Method references makes your code much more easier to read. Congratulations on learning a lot of concepts related to functional programming. I'll see you in the next step. Welcome back. When we started this section on functional programming, I talked about the fact that functional programming is all about giving first class status to methods. We said we would want to be able to store methods into variables, pass it to a method, and also return it from a method. We have been doing one of these very frequently. Try and think which one of those are we doing very frequently. And in this step, we would look at doing the other two things as well. We are talking about three things, right? One is storing functions in variables, two is passing them to methods, and three is returning functions from methods. What we have been doing, I'm taking the class Lambda behind the screens runner, which we have created a little while back. We are passing method. This is nothing but a method, right? A lambda is nothing but a shortcut to a method. So we are passing a method, a function, to a method. So to the filter method, we are passing the definition of a method. So this one we have already done. But storing functions in variables and returning functions from methods, do you think that's possible? Let's see how we can do that in this step. Now, right click, I'm selecting n mod 2 is equal to 0. Right click, refactor, extract local variable. I'm going to extract a local variable and I'll call this even predicate. So what we are doing in here, we are actually creating a local variable which contains the code that we would want to run. So now I can create another predicate called odd predicate as well, right? So I can create odd predicate and say it's is equal to run. What we are defining in here is methods, the code for a method. We are creating the method definition and an instance of it. This is storing functions in variables. Now, if you want to return functions from methods, you can do that as well. So I can take this and say right click, refactor, extract method, and I can say method name is, I'll again give the same thing. I'll say create even predicate, and let's see if there is a method called even predicate created in here. You can see that there is a method called create even predicate which is created in here. And what is it returning? It is returning a function back. It's returning a method back, right? All the magic of all these three is possible only because of functional interfaces. So even though we are actually defining the code for the method in here, what is happening is Java internally creates an implementation of this predicate interface. The same thing would happen in here. Java would internally create an implementation of this functional interface. In this step, we wanted to show that a function with functional programming is a first class citizen. You can store it into variables, you can pass it to methods, and you can return it back from methods. I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous few steps, we introduced functional programming to you. We discussed the concept of functions as first class citizens. We were able to store functions into variables, pass it to methods, pass them as return values. Now, these functional programming concepts open up a lot of new avenues for programmers. It enables us to write code which does not use mutation. Before functional programming, the only way to do sum of numbers would have been something of this kind. But with functional programming, you can go one level up. You can go from imperative style of programming. This is imperative style of programming because I'm exactly telling what to do and how to do it as well. In imperative style, we not only tell, okay, I would want to find out the sum of all integers. Nope, you are saying, okay, create a variable called sum, each time add it up and then return it back. That's imperative style. Function programming allows a declarative style of programming. You just tell what to do. For every two numbers, every pair of numbers, add them up. and return it back. Functional programming allows you to program at a level up, at one level up than what we usually do. Having said all this, functional programming is not really something which is intuitive to programmers, especially those who have a lot of experience with the imperative approach, which typically the object oriented programming and structured programming use. If you are looking at this functional code for the first time, then you would kind of think it's very, very complex, right? You would not even understand what's happening in here because we are used to seeing code like this. So if you are trying to introduce functional programming into a project, then make sure that everybody in the team get comfortable with all the concepts around functional programming before getting it in. And the most important thing is functional programming is an ocean. It actually deserves a book on its own. There are so many methods which are present on streams, there are so many different streams which are present, and there are so many new concepts that it brings in that it's really a very difficult topic to talk about. The idea behind all these set of steps was to introduce you to functional programming, to bring you into the thought process around functional programming. I hope I have been successful in that endeavor. Until the next section, bye bye. This video is part of a Java course with more than 250 steps helping you become an expert on Java. You can find the complete course details in the description of the video. Along with it, you can also find the details of a free PDF with 200 pages of awesome code examples in 28 minutes, creating great programmers.